Right. Okay. Right. Okay. Back to good morning. Almost afternoon. Right. For the term artificial intelligence is a unique term, right? What I mean by unique term, just like what we have now is where's my hand? You know that one. We have the unique name here is this one is mouse. Right. Actually, it's not mouse anymore because it doesn't have tail. The old one, the mouse with the cable, that's called the real mouse. But nowadays, because we don't have tail for what we call now mouse, then actually it's not mouse anymore because it doesn't have tail. I think the normal mice has tails, but now, so I don't know what you call it, but it should not be a mouse anymore, right? Okay. Now mouse is plural. Why we call it a mouse? I don't think we call it a mice. Still one mouse, not two mouse. Right? It's strange. Right. Okay. Just like artificial intelligence. It's what's it called? It's difficult to it's difficult to say in Indonesian. That's why it's unique. Artificial intelligence is a unique term, and even Google Translate doesn't have its own translation, still based on, well, people opinion, right? If you try to find the translation of artificial intelligence using Google Translate, then you end up with the translation in with what we call the people code in it. That means it's translation, the translation based on the opinion of people, not the translation itself. So this is the idea. Why we don't have the translation of artificial intelligence? Let me. Oops, I haven't shared. Okay, I turn off the video as well. Okay, I'm talking a bit about translation in Indonesian. Before we continue with my part, but I just want to say why we don't have the translation in Indonesian. You know that well, we translate this as, but what is artificial? So what is artificial in Indonesian? What is the translation of artificial? Now, in Indonesian, we have actually 3 translations. We have buatan, right? We have tiruan. We have palsu, fake. So, buatan is made. Maybe the closest one is tiruan, right? Now, why it's called buatan? First of all, why is palsu? Because it's not real. Sorry, not asli, not original. What is original? Means the original means made by God. That's original. Our intelligence is made by God. Or if we see that leg artificial leg, just like in 16 million $6 million man, 6 million. You know that it's a very old film. I was I think at that time I was still SMA. I think we have $6 million man. The film is you can check in YouTube what is $6 million man. It's a film where a man is well, I think this is the idea of RoboCop. You know, if RoboCop is all are replaced except the except the brain, but for $6 million man, it's replaced. Well, what is replaced is the leg, the hand, and the eyes. So we have artificial leg, artificial hand, and artificial eyes. Now, so if we talk about artificial leg, it's a palsu because it's made by. Why it's not original? Because made by man. Right? It's made by man, not made by God. Why is tiruan? Because imitate the work of original. So it's tiruan because artificial legs is imitate the work of real leg. And buatan because it's made by, I think this one I've sorry, palsu is not original. This one is made by man. Buatan is because made by human. So because we have 3 different translations, that's why artificial intelligence is translated It's not kecerdasan buatan, not kecerdasan tirusan, but still kecerdasan artificial. Why? Because we don't have the the exact Indonesian translation of artificial, because one may argue, I prefer buatan, I prefer tiruan, I prefer palsu. So to make it that we so that we don't have this some argument, then now artificial intelligence is translated as kecerdasan artificial. So it's just like something like, what is the translation of default? We don't have the translation of default. What is the translation of default? Likewise, we don't have the translation of machine learning. Learning. What is the machine learning? We don't also have the Google also doesn't have the translation of machine learning. Still use the the opinion of people. So that means in English we don't have the what we call official translation of machine learning. So up to now we don't have the official translation of machine learning. This one is already official translation in Indonesian by the government. But this one also, but actually this is not the exact translation, because we still use the word artificial. Just like machine learning, it's not the translation is not mesin pembelajaran, right? Because this actually is mesin yang belajar, the machine who learn, not learning of machine, right? Not learning of machine, but machine who learns, or machine that learns. It's up to you. Yeah, but that means the machine learning is machine that learns. This is the so what is the translation? It's mesin yang belajar. So this is there are many computer words that cannot be translated in Indonesian. So people use still keep using the English word instead of Indonesian word, just like mouse. Okay. Now back to the artificial intelligence. No, I'm not talking about the translation, because I've already explained. Oh, by the way, that's why our S2 study program in the Department of Computer Science is not the S2 of or Master Magister of Kecerdasan Buatan, but Magister of Kecerdasan Artificial. So this is the name of study program that we had in the department. Now, back to artificial intelligence. Now, now, if we talk about the intelligence, right? What we need the well, because a human is intelligent. This is because the human have a knowledge. Because people have knowledge, or because we have knowledge. If we don't have knowledge, then we cannot call ourselves is intelligent. We call it intelligent because we have knowledge. Now, where the knowledge come from? Right. So the knowledge actually come from the information or data. At the bottom of knowledge is data or information. So if this is us, right? So our knowledge, the base of knowledge is data or information we got. For example, if you go around or you go outside, or you are now listening to me, then you have a data or information, and the information becomes a knowledge for you. I ask you where you were from, then I got the data of the or information, and the data or information becomes knowledge for me. That, for example, well, probably about 40% of you are from Jakarta. This is the example of the knowledge that I have. So if somebody can ask how many students in your class from Jakarta, then I would say, well, about 40% of them from Jakarta, because I got the data or information straight from you. So knowledge is basically from the data. Now, from the data, sometimes the data come from other people. And then you have the knowledge from these people, because people learning from the data or information, right? So you might have the knowledge from other people, or the data can be come from how to draw the book from book. This is from other human. So from book you can have a knowledge. Also from environment. You can have data from environment, then you can have knowledge. And nowadays, data or information become knowledge to us through a machine. Machine means computer. Now the data or information Well, we know that book actually from the person. We cannot have book without person. So so actually it's not direct. The data become a book, but through human writing a book and become a knowledge to us. Book or written, actually written. Well, probably it's not book. It's a newspaper. It's also, we call it a book or written written knowledge. I would say written knowledge. Maybe it's not a book, written knowledge. Right? Maybe book, maybe something like a candi, yeah. Candi Prambanan, Candi Borobudur. It's not actually written, but they draw or whatever. But it's I would say it's written. Maybe it's not really written. Right? So from human can be book, right? Then we can have knowledge from the book or the written knowledge, or we can have knowledge for our environment, and also nowadays we can have knowledge from machine. Now this, because the knowledge come from the machine, this one human is learning, this one human learning from it, this one machine learning from it. So that's why it's called, this one is the idea of machine learning. Machine who learns, because machine learning from the data become a knowledge, then we use knowledge to make it this intelligent, or nowadays using the computer. Now because of artificial become computer. So human put the knowledge to the computer, book or written knowledge can be entered to the computer. From the environment, we can enter to the computer. From the machine, the computer, maybe other computer, put the knowledge in the computer, and then it become artificial intelligence. So this is the idea of the meaning of intelligence. Now, what is the form of knowledge? So what is the form of knowledge? Oops. Knowledge is based, actually, the form of knowledge, or one of the form of knowledge, is logic. What we have from the other people, from the book, from the environmental, from the right environment, or from the machine, what we have at the end is a logic. Right? Now there are two kinds of logics, which is propositional, propositional logic, And the second one is predicate logic. Propositional is simple presentation, but difficult to operate. I mean, it's not easy to operate the propositional. But for predicate logic, maybe it's not it's a bit difficult presentation, but it's powerful to operate. Or maybe it's easy to operate. So this is the idea of logic. So there are two kinds of knowledge. And you know that if we have many knowledge, then actually it becomes knowledge base. So what is the difference between database and knowledge base? Database is actually to be viewed or to be presented. But knowledge base is not. The difference between database is mostly for presentation. You just present the knowledge, but knowledge base is not just for presentation, but for, so you use the knowledge. So this is presentation of data. This is the usage of knowledge. So this is the difference between knowledge base and database. So database is just to present what is the data in any kind of presentation, but the important thing of the knowledge base is to use the knowledge. So the usage of knowledge. So this is the sorry. Now we talk about the first knowledge, first form of knowledge, which is propositional logic. Oops. So maybe Pak Zikri has already explained that we use the mathematics in AI. We need to have new knowledge, or probably the we call it conclusion, right? Now, as I mentioned, predicate logic is powerful representative scheme used by many AI programs. Propositional logic is much simpler but less powerful. But the propositional logic actually gave the idea later on for predicate logic. So that's why we start with propositional logic. You might have it in in logics. So I just a bit quick review. So in logic, symbol represent proposition or facts. A proposition is either true or false. Well, at the moment, we just use the proposition as true or false, but later on, maybe it's just not true or false. It's fuzzy. Maybe it's a bit different concept of, well, the extension concept of true false. And Boolean connective can join proposition together into complex sentence. So the later on. And sentence again are statements that are either true or false. So we just nowadays use true or false, right? Or you can say 0, 1. So that means the propositional syntax, the constant true or false and false. So true and false or 1, 0. You can say 1, 0 or TF. It's up to you. We call it as a constant. Symbols such as P or Q that represent proposition. So sometimes use, well, probably lower P or lower Q or capital P or capital Q. It doesn't matter actually. And then the logical connective is and or conjunction or disjunction, implication, equivalence, negation, or parenthesis. Now instead of for and, instead of using that symbol, so except for and, I use ampersand for and. So sorry, maybe it's a bit different. Uh, For and, I'm sorry that I use the ampersand. For or, using this one. For not, now for not is the line on top of the statement. For not, it's easier. Implication, well, this is the same, and equivalence or the implication. Implication, I use, well, it's still the same. Just except for and not, and not. Well, the parenthesis is the same. Then, so that means the sentence is true, false, or any propositional or any proposition symbol is a sentence, and is surrounded by parenthesis is a sentence. Disjunction, conjunction, implication, or equivalent of two sentences is a sentence. Implication of a sentence is a sentence. So then a sentence can be made from the true, false symbol, sentence symbol, or with connective symbol. Now, so a propositional sentence is valid if and only if it is true and all possible interpretation in all possible domains. For example, if today is Tuesday, then we have class. The truth doesn't depend on whether today is Tuesday, but on whether the relation is true, right? So if it's not Tuesday, today is not Tuesday, then becomes true. But if it's Tuesday and we don't have class, then it's false. So this is the example of the validity. Well, I'm going to give a bit if we have it's about negation. If we have uh, P, the house is big, and what is not P? Not P, actually the sentence become not the house is big. This is the original meaning of not P. So you just add not in front of the sentence. However, now if you compare with this sentence, if we have the sentence, the house is not big, this one is actually, I mean, I'm talking about the principle of sentence. Now, the house is not big, actually, it's not equal not P. Because you see, it's a different sentence. Now, we can say equals to based on the concept of sentence. Based on the concept of sentence. Based on the concept of sentence, then the house is big and the house is not big is actually not P. Not P is not the house is big. However, because we are human, this is because we are human. If it's in the computer, if you have the house is big and you say the house is not big, they say, well, it's not P. It's another, it's different sentence. If you talk about the computer or about the machine, so the house is not big is different with not the house is big. You see, the construction is different. This one is not P, but this one is not P. However, based on the meaning, because we are human, that's why I'm saying that human is smarter than computer. So this is the same by the meaning, by human. Sorry, based on the meaning, based on the meaning by human. So by the meaning of human, by the meaning of human, then they are the same. Not the house is big and the house is not big. But based on the concept of sentence, the house is not big is not equals to not P. So this is the idea about the now again, Now, if we have P and Q, then actually the house is big and the house is expensive. Okay, this is based on the sentence, but based on the meaning, this is by sentence. And this is by meaning. However, even by meaning, if you have two sentences, the house is big, the house is expensive, can we guarantee that this is the same house? Or if you talk in English, does anybody have like the opinion whether the house in P the same as the house in Q? Do you have any opinion? Anybody have the answer? If the house in P equals the house in Q, if it's not, then this one is not valid because it's different houses. Right? So if the house in P is different with the house in Q, then the first sentence is the correct one. But if it's the same, then you can have number two, but again, is by the meaning. Now, it's a bit different. It's a bit difficult now. How do we write? Can you write down and try to write in try to write in the chat. How do you write the first one and the second one? Okay. I stopped the recording. Honestly, for the first one, you should not change to or, even though they are the same. I mean, you use the Morgan, right? You change to or because you use the Morgan rule. Actually, the first sentence cannot be said in word. Because if I would say the house is not big and expensive, then it doesn't explain. Let's say this is in spoken, not written. If we say in spoken, the house is not big and expensive, see, then not is actually refer only on big, right? In this case, not big is actually refer for big, not the expensive. So this one is what I say, something that cannot be said in spoken language, because the house is not big and expensive, not reverse to big. You know the order. The order is parenthesis, not, and, or, implication, the same level. So parenthesis is the most important, because the order is, and then not, and or are the same level. Implication and implication also the same level. So that means if we have not big and expensive, means not only reverse to big. That's why it's sometimes it's easy to write in written language. So in written language, or in written, this is still this one. You can say not, oops, the house is big and expensive. This is the original one, because P and Q are the house is big and expensive, so just put N. So because this is the sentence. or you can put the bracket on it. But this one is also already explained because n is put here, behind this one. Or you can say with the bracket, which is uncommon in written as well, big and expensive. Or if you use a bracket, again, well, the original is not the house is big and the house is expensive. Because a sentence should be complete with subject, predicate, object. Spock. So this one is the original of P and Q. Most of them are correct. This one is the house is not big and not expensive. This is for the second one. For the first one is actually difficult if we don't use a bracket because we have this order, right? So the order is not n, but not is the order of not is higher than n. So this is the a bit example of how we write and how we speak in. I'm not sure if we can speak using spoken, because in spoken we don't have the probably the spoken is here, not the house is big and expensive. This is, I think, this is the we can say the even in the spoken language. So in spoken can be not the house is big and expensive. But in written, you can also have thus is not and then the bracket big and expensive. This is by the meaning. So that's why written and the meaning. But this one is the written by the machine. This one written by human. This one also written by human. But this one is written by computer. Okay. Now the next one is inference rule. So there are many patterns that can be formally called rule of inference for a propositional logic. And later on, this rule of inference will be used in predicate logic. This pattern describes how new knowledge or conclusion can be derived from the existing knowledge or knowledge base. both in the form of propositional logic sentence. Well, again, I will use different symbol as well. So when describing an inference rule, the premise specify the pattern that must match our knowledge base, and conclusion is the new knowledge. And we use the symbol premise implies conclusion. So I'm going to use different because I don't know how to select these symbols. I'm trying to find, but I'm sorry that I couldn't find it. So instead of using the symbol in our class, premise and then the symbol conclusion. I can find the symbol, but not that symbol in the in the slide. So instead of using this kind of symbol that it's difficult also to draw. So I'll use this symbol. Sorry about that. Now we have some inference rule. First is modus ponens. If we have x implies y, and we have x, then we can conclude y. And elimination, if we have n, all are n's, then every component of the n is also true. That means this one is actually saying if x implies y is true and x is true, then we can conclude y is true, or we can conclude y. If we have this one is true, then we can conclude that all xi are true, is true. And introduction, if every single is true, then we can add, if we end them, then becomes true. For our introduction, if one is true, then we can or any sentence and still the sentence is true. Well, I think you're familiar with double negation equals the original x. And this one is unit resolution. This is the same as this one. Why the unit resolution the same as modus ponens? Why they are the same? You know that the modus ponens, P implies Q and P, then we can conclude it's Q. Now, now P implies Q is actually equal to not P or Q, and then P implies Q. Now, if we replace not P with P or Q, then P replaced with not P. Not P implies Q. Also, we can use this modus ponens with the modus tollens. So we can have the modus tollens. If we have not Q implies not P, oh sorry, not this one. If we have Q implies P, this one equals to not P implies not Q. So if we have not P, then we can conclude not Q. Oh, sorry, this one different. Now, what is not P or Q? So if we have this one is not P or not Q, implies not Q. And this one is P. Now, if we replace not Q as Q, and this is not P, then we can have, we replace not Q with Q, and this one is also Q. So this one is the same. So this is the unit resolution. And then for composite resolution, we know that if P implies Q and Q implies R, then what we have is P implies R. So that means if we have not P or Q and not Q or R, we have P or R. And then oh, sorry, should be not P. Wonder it's different. This one is not P. Oh, sorry, P. Sorry, P implies R is not P or R. So if we replace not P with P or Q, and we have not Q or R, then what we end up with P or R. So this is the resolution. So we have resolution one and resolution 2. This is we call unit resolution because we only have one sentence, but this one rule of inference. Now we use this resolution to prove a sentence. So how to prove the sentence or finding a proof? So if we have a knowledge base, which is a set of propositional sentence, a goal stated as propositional sentence, and the list of inference rules that we already had, we can write a program to repeatedly apply inference rule to the knowledge base in the hope of deriving the goal. So this is the example. It will snow or there will be a test. Dave is Darth Vader. I think Dave is the father of Luke Skywalker, but now Darth Vader is replaced by Ben Solo, right? So you can say Ben or whatever, or it will snow. Then Dave is not Darth Vader. Now the question is, will there be a test? Or is it true that there will be a test? Right. Now we have snow, test, and Dave is Darth Vader. So we have three sentences. Let's say P is a snow, Q is test, and R is Darth Vader. Dave is Darth Vader. Darth Vader. Now the first sentence is, it will snow or there will be test. Number two, Dave is Darth Vader or there will not be test or there will be test. Let me check again. There will be test. Oh, sorry. No, there will be test. That is Darth Vader, or it will not snow. Sorry, it will not snow means R or not P, and three that Dave is not Darth Vader, so not R. So the goal is Q. Oh, there will not be snow. Okay. Now the idea is we use the this one is, if we have this knowledge base, this one is considered N. So that means 1 and 2 and 3. So that means because of 1, we can have this. This one is true. So the all, that means all, if we combine the 3, then it's true. Right. Now, what if we combine 1 and 2? One is P or Q. Number two is R or P, not P. Now we have P and not P. Remember that we have P or Q and not Q or R. We can conclude P or R. So this one we have a Q or P because we can replace, we can swap, and not P or R. So this is exactly the same, except that Q now is the row of Q replaced by P and the row of P replaced by Q. So that means with these two, we have number three, we have new knowledge, which is Q or R. Now we have number three is not R. Remember we have P or Q and not P. We conclude R. Oh, sorry, Q. Now we have R and not R, P and not P. This is the R. Then we can conclude number five is Q. So it's proof that Q is true. Now this is the solution, the same, exactly the same, A or B, C or not A, not C. The resolution we know B or C is true, and you need the resolution we have no B is true. So that will be that. So the actually developing a procedure, deriving a goal from a collection of logic facts correspond to research 3. A rule inference could be utilized, the selection of which rule to apply and when would itself be non-trivial. So actually it's not easy. For small number of knowledge, maybe it's easy, but if we have a huge number of knowledge, then sometimes we have to do what we call it trial and error. Okay. Now we use the what we call it CNF. It's another we call it CNF, or closed form or conjunctive normal form. Now, CNF has three properties. Every sentence is a conjunction of literal. All sentences are implicitly conjuncted. So as I mentioned before, that this one is considered N. Now in CNF, all sentences contain or not of one literal or one atomic. So this one is actually the form of CNF, because this is or and not is only one sentence. We cannot have we cannot have negation of two sentences. So we need to have the you need to have the not only one atomic sentence. So this one is already CNF. Any propositional logic sentence can be converted to CNF. We need to remove all connective other than or without modifying the meaning of a sentence. So we need to use the equivalent of or, right? So eliminate implication and equivalence, reduce scope of all negation to single term, use associative and distributive laws to convert to a conjunction or disjunction, create a separate sentence for each conjunction. So that means for implication, use the Morgan itself. So for example, if we have P implies Q, then we can written as not P or Q. If we have P and Q, we can have not P or not Q. If we have P or Q negation, we have not P and not Q, and we come to sentence not P and not Q. If you have B implication, P Q is 1 equals to not P or Q, implies Q, and Q implies P. So that means becomes P implies Q, two sentences, Q implies P, and this one not P or Q, and this one not Q or P. So this is the so reduce two ones or with or, because we have and, then we can have spirit sentences. I think this is already done. Yeah, just like double negation become X, and this one using the Markov law. So this become the two sentences. Associative using distributive. Oh yeah, distributive. We have if we have P and Q or R, then we have P and then Q or R. But if we have P or Q and R, then we have equals to P or Q and P or R. Then we come to sentences, which is P or Q and P or R. So this is the, so we don't need distributive for this one, but we need to have distributive here. Here you just split into P and Q or R. But if you have P or Q and R, then we have to use distributive P or Q and P or R, and then we split P or Q and P or R. So this is the now how do we use the CNF? So first of all, consider all propositional sentences that are in the knowledge base to CNF. And this is important. Add the contradiction of the goal to be proved to the knowledge base. So I would say is augmented knowledge. Yeah, it's not the knowledge itself, but it's augmented. We augmented to the knowledge, so it becomes knowledge base. Use resolution as a rule of inference to prove that combined facts cannot all be true. That means the idea is from the from all the augmented knowledge, we can infer a contradiction. Right. So if we can derive a contradiction, so the idea is first of all, we have knowledge base. Knowledge base in CNF, or I would say KB. And we have goal, let's say G, and add the negation of goal to the knowledge base. So knowledge base plus not G. My term is augmented knowledge base. We and also this one should be also in CNF. So if it's not just one sentence, two sentence, then convert to CNF. So that means augmented knowledge base now are in CNF. Now, if from knowledge base to from augmented knowledge base, we can invert we can derive a contradiction. What is contradiction? Is two sentences, X and not X. We don't know which one of the X, but we can infer or we can derive a contradiction. That means the augmented means if we can prove that we have X and not X, that means augmented matrix. Augmented knowledge base is wrong or false. However, knowledge base is true. I mean, all the knowledge in the knowledge base are true. Now, because augmented is false, this one true, this one false, because we and, sorry, not plus, but and. Now, because if this is true and this is false, that means not G is false. That means not G is false. That means G is true. That's what we are going to prove, that G is true. Now, using the first, using the example before, P, oh, sorry, P or Q are, sorry, R or not P, 3 not R. And the goal is Q. So that means the augmented is number 4, not Q. Oops. Not Q. Remember, this one is supposed to be true. Otherwise, one is false. So if we have number 1 and number 4, P or Q, number 4 is not Q. You know, we have Q and not Q. We can infer number 5 is P. Now we have P, and number 2 is R or not P. Again, we have P and not P. Then what we have is R, number 6. Now, number 6, if we have number 3 is not R, so R and not R is a contradiction, or it's false. False means contradiction. So that means because we can infer a false statement, that means not Q is false and Q is true. So we prove by contradiction. We assume that all original facts are true. We add new fact. The contradiction of sentence we are trying to prove is true. If we can infer that false is true in this contradiction, now the knowledge base is corrupt. The only thing that might not be true is the negation of the goal that we added. So it must be false. Therefore, the goal is true. So we have knowledge base P and Q implies R, S or T implies Q, and T, the goal is R. Let me write first. P and Q implies R, S or, is it correct? P and Q, S or T implies Q. Number 4, T, and the goal is R. Okay. Now, what about number 2? Number 2, we have P and Q, the negation or R, and this one P or Q or R. Sorry, not P, not Q or not R, or not P or not Q or R. This one is S or T, negation or Q. That means we have not S and not T or Q using distributive. Yeah. Oh, because this one is OR. So not S or Q and not T or Q. Because we have N. Now we have two sentences. Let's say 3A is not S or Q, and 3B is not T or Q. And because the goal is R, then we add number 5 is not R. Now, we can, let's say, well, I'm going to use 4, which is T, and 3B, which is not T or Q. So we have T and or Q, then we have, let's say, number 5 and number 6 is Q. We cannot use 3A because this one not S or Q. So we can use number 1, which is not P or not Q or R. So we have not Q and not P. So the We have the rest is number 7, which is not P or R. Let's say I use number 5, which is not R. We have R and not R. The important is one is negation of the other. Then we have number 8 is not P. And not P. And we have number 1 is P. We have false. Because not P and 1P, we can conclude false. Now, because we have false, then what we have now is not R is false and R is true. This conversion to CNF are the same, not contradiction, not R, resolution. Well, this is different way. Not P, not Q, or R with not R, we have not P or not Q. And then we have P, not P, then we have not Q. We have not T and or Q and not Q, we have not T, not T, we have T, then is false or not clause. There's no way all the clause can be true. So not T and this one true. This is the intuitive look at the same example. Then you can read. Now, propositional logic limits the expressive power of propositional logic is limited. The assumption is that everything can be expressed by simple facts, but which is not true. It's much easier to model real-world objects using properties and relation, and then predicate logic provides this capability more formally and is used in many AI domains to represent knowledge. And you can try to find this information. If unicorn is mythical, then it's immortal. If it is not mythical, then it's immortal. Mammal, if unicorn is either immortal or mammal, then horn, the unicorn is magical. If it is horn, then you can prove which one is true. Okay, this is all for today, guys. So see you next week. Wait for the information whether online or offline. So thank you very much for joining the class. Don't forget to check the attendance in ELOC.